Okay, brother, here I want to give you a quick rundown before I tear the whole box apart what I got to do. I got to repair your relay, which isn't hooked up anymore. And then, like this wire here, that's your positive lead for your 2-pill. It's not made of Teflon. This lead's not made of Teflon. That lead's not made of Teflon. That's Teflon. This is not Teflon. This is also not Teflon. And I need to replace this. This choke is not Teflon. Neither is this here. And if it's Teflon rated wire, I should be able to put my soldering iron into it and it not burn. So for safety reasons, I'm going to change all that out. I'm going to replace these small relay or these small resistors. I'm going to change out these caps to actual metal mylars, and we're going to replace that variable to a real one. So I wanted to give you a quick update before we got started on your little a TX400. All right, brother. I appreciate you sending this up. Give me a minute and we'll get her all fixed up. Oh, by the way, red fan. See you, bye. Let's see. I think I got everything on. Yeah. All right, brother. So, turn the radio on up here and turn the peak kit on. Here is everything I had to replace inside your box. I had to replace every single tuning capacitor inside the amplifier. The dual 550s, he had them up here. So these are 550s. If you take two of them, focus, come on. Focus. If you take two 550s and tie them together like this, or 560s, I mean, you're going to get, what, 1200 puff. Well, that extra 120 puff is enough to make the box run like dog ass, okay? So I went ahead and I replaced those with metal clad capacitors, completely redid all the solder work inside the box, then had to change the output tuning cap. That was the wrong value. This was the wrong value for the driver section. This was the wrong value for the input for the driver section. This was the wrong value for the output of the driver section. I went ahead and I replaced all these little weak, like half-watt resistors. I replaced everything with 5-watt inside the box. Went ahead and resecured your relay, so it's back in there. Replaced the power feed mechanisms that feed the the output transformers. Replaced your power wire with new oxygen-free stinger cable. Got rid of this. Okay, I don't know where this variable came from, if it come from him or not, I don't really care. This is woefully inadequate. Now it says right on the side that it is 100 ohm. Yeah, we're just going to go ahead and we're going to throw that away. Never want to see that again. Throw that away, never want to see that again. Throw this away, never want to see that again. Now, the biggest thing, one of the biggest things, is he had this piece of wire. And this piece of wire was attached here from the output of the driver section to the input of the driver section. Now, if you look at the first portion of the video, you'll see that I had to change the windings. So I went ahead and I rebuilt your splitter and your combiner. I had to rewrap both your input transformers, rewrap your chokes, rewrap your input transformer on the driver section, rewrap its choke. I went ahead and replaced the wire with the little shmew resistor in it and replaced it with a piece of 316 coax. True 50 ohm coax instead of having a piece of 100 ohm wire bouncing around inside. Now my biggest pet peeve with the Blue Label boxes like this is that they're wired with non-Teflon wire. Okay? This is a big deal. Let me show you why this is a big deal. The jacket on this wire is very prone to abrasion. And what I mean by abrasion is this, like here, he had the wire run underneath these disc capacitors. Now I've replaced everything in this box is now Teflon wire. So this is what I call automotive safe. If it goes underneath this component, you see that leg that's on the component? Well, the wire, grab this resistor as a visual aid, the wire can chafe underneath that leg. So over time, it can wear through the little jacket, which is soft enough for you to screw it up with your fingernail. Okay. And you have an electrical short. Now, we're not going to take into account, that's just the vibrations. The other thing that we got to take into account is heat. This amp is going to run, let's say on a good day with the air conditioning running in your truck, and you're going to pump in probably 75-degree air, and it's got to deal with the heat. The heat dissipation is 6 transistors at about 120 watts worth of dissipation per transistor. So there's got to be 600 watts worth of heat generated every single time you key the box. That gets radiated into the heat sink, transferred via the fan, and exhausted out of the cabinet. Well, the board gets hot. Okay. So here's just a couple 100-degree soldering iron. Just give it a quick little touch. Just quick touch. Look at that. Melts right through to the wire. To me, this is super dangerous. So I went ahead and I replaced everything with Teflon-based or TEFE wire. So we'll give this a long touch. A long touch. Nice big long touch. I'm burning the friggin' towel. Nice big long touch. Hold it down there. Get it nice and hot. Won't burn. Won't melt. Won't deform. Because this is made of somewhat heavier material. Oh, and the wire on the inside is silver plated and stranded. Way better than this copper-based wire that's in here. Okay? The other thing that we need to think about is this. Instantly, as soon as it comes in contact with the flame, on fire. Okay? The BBI is burning too. Actually, no, it's not. What's burning off is the little blue dye strip. Just look at that. The little blue dye strip. The wire is not deformed. It's not melted. Nothing. Let's check it out. Just a little bit of schmutz. I'll wipe it with my fingers. There's nothing there. Didn't burn it at all. So the moral of the story is your amp is now safe. And I guarantee it's going to run way better than, well, what it was doing before. Now, I used 6 matched Toshiba 2879s in it, the driver's section and the final section. I went ahead and nerfed the drive section so it can't overdrive the output section. So now I'm 14 volts with almost no drive. So let's run around the band here real quick. Got a 1000 watt slug in PEP, 1000 watt slug in average, 5 watt slug in reverse back from the Bird 10,000 watt dummy load. Now check this out. Hello, audio. Hello, audio. Hello, audio. You keep stressing to me on text, man, my radio does 35 watts. Great. My RCI 2950 does about 35 watts too. Hello, 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 audio, hello. Is this thing even oh my God, look at this. Jesus, it's making 1,000 watts of power and it wasn't even plugged in. Hello. There's our full 1,000 plus with about 30 watts of drive. Hello, audio. 300 plus Bird. Hello, hello, hello. Let's go look at our input tune. Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. About a half a watt. Basically, perfect. Perfect is the only way to put it. Now, what we're going to do here real quick is you said you wanted red. I said, BBI hooked me up with blood red. I said, man, you got it, brother. So what's in there now, and I'm sorry for the noise, there's nothing we can do about it. It's from the waffle stomp pattern that's in the lid of this amp, okay? Look at this. Gotta keep the retardedly big screws that he uses from falling in the fan, but it makes the fan really loud and it also restricts the airflow. You got adequate amount of air coming out of the box, but you've got an Evercool 120 millimeter ball bearing fan in here. Now, the fans that I have are blue, green, and supposedly red. Come to find out, the red ones I've got 4 little tiny piss-ass little LEDs in them, and you could barely even tell the fan was on in there. So what I did is I went and I wrapped the 120 millimeter fan, wrapped it with big cob LED strip. So this is super big LED cobs. They're like the end of a pencil. Made it go all the way around, and that's the reason it's so bright. But brother, your box is working perfect. Tits spot on. Everything in this now is Teflon, so it's automotive safe. It's heat resistant because of all the Teflon, which makes it automotive safe. And on the up note, it's working like a wet dream now. Hello. Hello. 14 volts. Hello. Hello. 107 amps on the low side, 124 amps on the high side. We do the math, that's about 65 to 70% efficient, which is spot on the money. Well, brother, I appreciate you sending this thing up to me, giving me the opportunity to go through it, make it right, make it look pretty, and make it run really good. I appreciate that like more than you could ever possibly believe. So gentlemen, I'm going to say this. On this note, I'm out. And I'm going to mosey on and go do some other things. Gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. Come find us on Facebook, Twitter, Snapchat, Instagram, and of course right here on YouTube. And if you're watching this video for the very first time, my God, for God's sake, click subscribe. I gotta go. I'll see you boys. And brother, when you get it back, there might be a new logo on the front. Bump, bump.